इंटरफेरेंस और डिफ्रैक्शन में बेसिक फ़र्क क्या है? So this is the interference and this column shows the diffraction. So first we'll start with the first point is the interference pattern has the number of equally spaced bright and dark bands. You can see in this diagram, here is the figure number 1. This is the figure number 1 I have drawn for you, and this is the figure number 2 to study about. So the figure number 1 shows the interference pattern has a number of equally spaced bright and dark bands. आप जहाँ यहाँ ध्यान से देखिए, ये देखिए, ये जो bright bands है, ये the green color आप देख रहे हैं, this part is and this part, they are all of equal width. ये सब equal width के हैं. So this is the first point of difference is that in interference pattern has the number of equally spaced bright and dark bands. ये सब bright और dark band जो हैं वो उनकी जो width है वो equal है. So you know that fringe width beta is equal to d lambda upon d. So but in case of diffraction pattern, here there is the single aperture AB we were discussing about. ये जो AB है, this is AB, and the parallel wavefront that falls on this aperture AB, it will diffract to some angle lambda by A. But here in this case the diffraction pattern is like that, all the bands are of unequal width. So diffraction pattern has the central bright maximum which is twice as wide as the other maxima. आपने अभी थोड़ी देर पहले ये किया था कि जो बीटा 0 है is a width of a central maxima, it's 2 times the width of the secondary maxima. This is what we have done in the expression earlier also. The second point of difference is that the intensity of the either side of maxima will remain the same. आप यहाँ गौर से देखें तो जितने भी आपको bright bands, green पट्टियाँ दिख रही हैं, ये सभी बिल्कुल बराबर चमक रहे हैं. This means कि intensity of light on the screen on the bright bands will remain the same, whatever you're talking on the upside of the screen or downside of the screen. But in case of the diffraction pattern, see here, इस पट्टी को, जो बीच वाली पट्टी को आप गौर से देखिए, आप बीच वाली पट्टी को गौर से देखने के ऊपर आप पाएंगे कि जो सेंट्रल फ्रिंज है वो ज़्यादा ब्राइट है. इंटेंसिटी फॉल्स एज वी गो टू सक्सेसिव मैक्सिमा अवे फ्रॉम द सेंटर ऑन द ईदर साइड. आप देखिए यहाँ the central fringe is more bright and then brightness is goes on decreasing. हमने पढ़ा था जो इंटरफेरेंस, जो डिफ्रैक्शन पैटर्न, उसमें हमने पढ़ा था कि जब डिस्ट्रक्टिव इंटरफेरेंस होती है then path difference is equal to lambda by 2. So for the secondary maxima we'll take, there are 3 sections of this aperture, and the first 2 contribute to the destructive interference, while the third one contribute to the constructive interference, so that the intensity of this band will decrease. But for the another secondary maxima, for second secondary maxima, there will be the 5 parts of this aperture, and then 4 will contribute to the destructive interference, and then 5th will contribute to the constructive interference with this path difference lambda. And then for another one, this for this, and this for this one, the third one, the seventh part of this aperture, after division, it will only contribute to the constructive interference. So as the case that the intensity of this these bands goes on decreasing as we go up or down to the down around the central maximum, right? So the third point of difference is we calculate the interference pattern by superposing the 2 waves originating from the 2 narrow slits. जब हम इंटरफेरेंस पैटर्न को पढ़ते हैं, आप यहाँ गौर से देख सकते हैं, सारे का सारा पॉइंट ऑफ डिफरेंस जो है यहाँ, ये देखिए, ये सिंगल सोर्स ऑफ मोनोक्रोमेटिक लाइट है, और उस सिंगल सोर्स ऑफ मोनोक्रोमेटिक लाइट से हम यहाँ 2 कोहेरेंट सोर्सेज जनरेट करते हैं, S1 and S2. And these 2 coherent sources of light are responsible for the interference pattern we are watching here on the screen, placed at some distance d. इस d डिस्टेंस के ऊपर जो हम स्क्रीन को रखते हैं, तो वो जो इंटरफेरेंस पैटर्न है वो 2 कोहेरेंट सोर्सेज की वजह से होता है. बट आप यदि डिफ्रैक्शन पैटर्न में आप देखें, so there is only single source of light. The light, a plane wavefront will strike on the aperture AB, which is very narrow, and then you will observe the diffraction pattern on the screen. So here diffraction pattern is a superposition of a continuous family of waves. Now this is very important for me to explain this. originating from the each point on the single slit. देखिए सिंगल स्लिट में क्या होता है, हमने आपके साथ एक डायग्राम बनाया था जब आपको सिंगल स्लिट का डिफ्रैक्शन पैटर्न एक्सप्लेन किया था कि ये देख लीजिए, ये आपके पास एक सिंगल स्लिट है, हम यहाँ इस तरीके से इसको रिप्रेजेंट कर देते हैं और इस अपर्चर के बीच में जब एक प्लेन वेव फ्रंट बनता है तो यहाँ छोटे छोटे पॉइंट हमने चूज किए थे ऐसे ऐसे करके. Okay, we have marked some points C over here, AC and BC. Then these sources, these small points on the plane wavefront, the primary wavefront will be the source of the secondary wavelets. All right. So this is what the meaning of this sentence is. The diffraction pattern is a superposition of the continuous family of waves, and these family of waves are generated by the all the points on the primary wavefront. Right. So this is the cause of the diffraction pattern. And the fourth point of difference is at the same angle lambda by a we will get the maximum lambda by a, because see this is the theta, this is sine theta, this is sine theta. Condition is a sine theta is equal to lambda. So if the path difference is equal to lambda, this is the condition for the constructive interference, right? So this is in the case of the interference, but in case of diffraction, when you break up this into two parts, you just remember that diagram. This part is Bn and this part Cm, as I have mentioned over here. So this when the wave will come out from this point and wave will come out from this point, they will lead to the destructive interference because the path difference between Cm is equal to lambda by 2. So जिस वैल्यू के ऊपर कंस्ट्रक्ट इंटरफेरेंस पैटर्न में आपको मैक्सिमम दिखता है, उसी वैल्यू ऑफ द पाथ डिफरेंस के ऊपर जो डिफ्रैक्शन पैटर्न है उसमें आपको मिनिमा दिखता है, डार्कनेस दिखती है. So that is the explanation of this line. At the same angle lambda by a, we get the maximum on the screen for the two narrow slits separated by a distance a. So we are talking about this. We get the maximum at this point, but here we will get the minima at this point, right? So for the single slit of width a, the first null point, that is the minima of the interference pattern, occurs at an angle of lambda by a. You do remember this sine theta I. The condition for minima is theta n is equal to n lambda by a. So this is what I'm talking about, right? So this is all about the difference between the interference and diffraction pattern.